This paradox has been described in many different ways. What you watch here is equivalent to all the other descriptions online or in videos as far as the essence of the paradox is concerned. Here is the basic setup. We have an infinite number of balls that are distinguished by numbers on them. There is also a chute that's open at one end where the balls may go in. The other end we have a handle that when pushed allows one ball to drop to the floor. What else we see here is the first step of the process where we simply put ball number 1 into the chute. The next step consists of removing ball 1 and dropping the next two balls into the chute. Here we pull the handle, ball 1 drops out to the floor, and we pull the next two balls 2 and 3 into the chute. In the end, we have ball 1 sitting on the floor and balls 2 and 3 sitting in the chute. All right, let's show one more step. Step 3, we release one more ball by pulling the handle. Ball 2 goes down to the floor, and we put in balls 4 and 5, two more balls. At the end of the third step, we have 3 balls sitting inside the chute and balls number 1 and 2 sitting on the floor. We repeat this process over and over again, basically adding 2 balls while releasing 1 ball from the chute. Here's a summary of the first 3 steps. Notice that looking at the chute only, in step 1 we have just 1 ball inside the chute, ball number 1. While in step 2 we have an additional ball, 2 balls inside the chute. In step 3 we have 3 balls inside the chute, and so on. If I go on to step 4, in step 4 we'll end up with 4 balls inside the chute because we release ball number 3 to the floor. What's left is balls 4 and 5, and then the newly added pair of balls 6 and 7. So we have 4 balls inside the chute. The number of balls inside the chute goes up one at a time without end. The process doesn't end, so there will be an infinite number of balls inside the chute. On the other hand, looking at the floor only, at the end of the second step we have ball 1 sitting on the floor. At the end of third step, balls 1 and 2 are sitting on the floor. At the end of the fourth step, we have balls 1, 2, and 3 on the floor, and so on. As we keep going in this fashion, all the balls that we started with wind up on the floor. Ball 1, 2, 3, 4, etc. There is no stopping them. So in the end, all the balls that we started with wind up on the floor, and therefore nothing should be left in the chute. And that's the paradox. I will explain what's going on in detail in part 2 of this video. But for now, let's concentrate on a couple of additional points regarding this paradox. First, the paradox still works out, it persists, as long as we add more balls to the chute than we remove from it. So for example, we could add 3 balls at each stage rather than 2, or we could add 10 balls. This is for no essential reason. This is the most common number used in descriptions of this paradox. But not only these, we can add a variable number of balls at each stage. We could add 2 balls in even numbered steps and one ball in odd-numbered steps. And again, what we will find out is that the number of balls in the chute becomes infinite, while at the same time, all the balls that we started with end up on the floor. You may want to pause this video if you're curious and work this out, see what you get. Descriptions of this paradox very often invoke the concept of supertasks, which means doing infinitely many tasks in finite time. For our particular problem, this could be something like this. Let's say we measure time in minutes. Step 1 takes half a minute. Step 2 takes a quarter of a minute. Step 3, an eighth of a minute, and so on. If we add up all these fractions of the minute, we get 1 minute. Because of some of this particular geometric series is just 1 minute. Well, of course, we are doing things faster and faster. Step 3 is 1 quarter of the time to step 1, and so on. So we are actually doing things ultimately at infinite speed, and that simply replaces what we just did with constant speed over an infinite time interval. So there is really no other difference, and this distinction involving supertasks has no bearing on this problem. We don't really need to invoke supertasks. Finally, let me mention that there is I'm using a story-like description of this paradox in my book Achieving Infinite Resolution, which is linked in the video description, involving the fortunes of two elves, greedy and generous. And it's pretty much the same problem, but a little bit different style. Okay, that's it for us here. Hope to see you in part 2. Thanks for watching.